This lesson is 8M3 Lesson 5, First Consequences of the Fundamental Theorem of Similarity. So yesterday we learned that the fundamental theorem of similarity told us that when we take an object or a line, a segment, and we dilate it by a factor, a scale factor r, that the final line segment that is scaled or that is dilated is parallel to the original line. In addition, the length of that line segment is equal to r, the scale factor, times the length of the original line segment. So that's a lot of words. Let's remember. We'll show you in on paper what that looks like, and we're going to learn about some consequences of that. We're also going to use the fundamental theorem of similarity to answer some homework problems from 8M3 Lesson 5. So if you're looking for some specific help on the homework problems, just kind of fast forward this video kind of to the second to the last slide and the last slide where we work some problems. Okay, let's move on to our lesson for today, or our lesson help. As you know, this is not, the videos that I'm doing are not meant to replace the lessons that you're learning in class, but to augment them. These videos would need to be more like an hour to completely cover all the information in class at a very detailed and first-time level. But these videos that I do, again, meant just to kind of help you out and solidify what you are learning in class. So let's look at this first problem. This first problem is actually from the work that you did in class today. And you're given these two lines, PQ and P prime Q prime, and you're told that P has been dilated to P prime and Q has been dilated to Q prime from a point zero, from a center O, which they actually don't show you here, and with a scale factor of R. And they don't tell you where this center is, and they don't tell you where this scale factor is. However, they do tell you that one, these 2 points have been dilated, and number two, that these lines are parallel. Well, that's, you don't need to know that, because the fundamental theorem of similarity already tells you that those lines must be parallel. Because if I dilate P to P prime and Q to Q prime, the line segment PQ and the line segment P prime Q prime, they must be parallel. PQ and line segment PQ and line segment, this is the notation we use for line segments, must be parallel by the fundamental theorem of similarity, the FTS. It tells us they must be parallel. So now the question is how, where is, let's try and find this center O. Well, one thing I know is that if I dilate at point P to P prime, it must be along a line. The center O has to be on a line backwards from P to P prime. So if I draw a line here, whoops, let's do it like this. Let's go like this. I'm going to draw a line that goes all the way back. Like that. I know that O, my O must be somewhere along that line, because if I dilated it, point P to P prime, it must go along that same ray. Okay, so let's draw in a different color. Let's do the same thing with Q and Q prime. So I know the origin must be, or the center must be on this line. So who can tell me, or can you tell me more accurately, can you tell me where the center must be? If it has to be on this line, and it has to be on this line, then our center must be right here. And so we're going to draw that in and call that point O. All right. Now the second thing So that's A. No, sorry, that's point B. Or that's B. Now, the scale factor R can be determined by looking at the size of our dilated object and the size of our original object. Because remember, the answer, the fundamental theorem of similarity, also tells us that dilated objects, let's just say line segments, are R times the length of the original. Okay, so let's look at that in this case. So our original object is, and let's just put this in this color. So our original is PQ. And when we say means line segment, the length of a line segment we say like this. So if we take our original line segment and we multiply it by R, we get the length of our final line segment. But we know the length of our, right? This is the length of our original line segment, and this is the length of our final line segment. So we can just plug those in here. The length of our original is 5 times the scale factor equals the length of our final. So if this is true, 5 times R is 10, then R must equal 2. And that's our answer. The scale factor is R equals 2. So we're going to use this a few times, this concept, FTS, in a couple different ways. But the key, one of the keys to, and we're going to use it on some of the problems that are going to help you on your homework. But the first thing, and this is kind of they call it the lesson summary, but there's actually more that you learn in the lesson than just this lesson summary. But it basically is telling you that if you have two parallel lines like this one, PQ and P prime Q prime, two parallel lines, and we can draw two more parallel lines right here just for fun. Oops. Two parallel lines like this. If we take two parallel lines and we have dilated each one like P and Q, and we've dilated them to points P prime. Oh, sorry. What it's saying is that if we have two lines that are parallel, and P prime Q prime is R is longer. It's R times longer than this line. And we've dilated, then there is a point O that's out here somewhere. Then there is a point O that can be used to dilate P to P prime and Q to Q prime. That's all it's saying. And that the scale factor is actually the lengths, the relationship of the lengths. And the scale factor is P prime Q prime, the length of that divided by the length of the first one. So just like we did here, we could take a line and we could find our center, right, by doing this correct. We could find the center. We know that, and we can also find the scale factor by just taking the length of this line and dividing it by the length of the other line, like we did here. Basically 10 divided by 5 was 2. So that's all that's saying. If you have two parallel line segments in space, then you can find a point that they're dilated about, and you can find the scale factor by simply dividing their lengths. That's what it's telling you. Okay, so let's put a bow on that one. Big happy cat. And let's move on to two problems that are similar to problems that you're going to see on your homework. So I'll write that up there. This is homework help. Homework help. So bear with me. So let's do this. We want to find point A is dilated using a scale factor of 7/5 about center O. Locate A prime. Okay. So one thing I can do is I can use some math. I can measure the length. Let's do it the long way. I can measure this, I could make a really long line like this. And the first thing I can do is I can measure this distance. And whatever that distance is x. I can use a scale factor of 7/5 and multiply it by x to find A prime. And that's the way we've kind of been doing things. And so that would be 7/5 times x. And then we'd find A prime, and it would be out here somewhere. But let's not do it that way. Let's get it exactly right. Let's use a trick that we've learned and get it exactly right. So watch what I do here. I'll do it kind of slow. We're going to make a parallel, or we're going to drop this line down straight to here. And we're just going to call that point B. Let's start that again. Let's go right on the line. Okay, and we're going to call that point B. And I'm only doing this to help us solve this problem. Now, what do I know if I now dilate these 2 points by 7/5? Well, I can easily dilate point B, and let's do this one in blue. I can easily dilate point B by 7/5. Right? Because B, from O to B, the length of OB is 5. So if I dilate it by 7/5, I go 7/5 times 5, and that's going to equal 7. So 7/5 of 5 is right here. This is going to be my B prime. Right? This is 5, so I go 7/5 of 5 is B prime. Now, what also do I know about lines AB and line segment AB and line segment, well, wherever A prime is, what do I know about the relationship between AB and AB prime? Well, the fundamental theorem of similarity tells us that AB must be parallel to A prime, B prime. So I know that this line here, wherever it is, it's got to be straight up and down. If this one's straight up and down, parallel is also going to be straight up and down. So let's make our line that goes straight up and down. And voila, what do we have here? What have we found? We found A prime. Because we know it's got to be, this line's got to be parallel to AB, but A prime has also got to be along this line here. Because that's the line, this is the center of dilation. So we have found our point A prime. See that trick? We don't know how long this is, but we do know how long this is. And then we can use our fundamental theorem of similarity to find that, to find point A prime. Okay, so let's put a big happy cat on that. I know this is a little bit, it's like, how did Mr. Lipscomb know to do that? Well, this is just kind of a trick, but after you see the trick once, you'll know how to do it again. And then you're going to start to see these things, these triangles that are the same shape and size. And you're going to see how we can shrink and grow triangles to help us figure out where points might live when they're dilated by shrinking or growing them. And this concept of similar, they call them similar triangles, is very powerful. Okay, and what else do we know? Let's just see what else, remind ourselves what else we know. If these two triangles are similar, OAB and OA prime B prime, we know that these angles are equivalent because they're corresponding angles. These are equivalent, and these actually turn out to both be right angles. Okay, let's now move on to our last piece of homework help. This is homework help. Homework help number 2. Okay, so we want to dilate the points A, B about center O using a scale factor of 4/11. So what is 4/11 going to tell us? Think about that. Is it shrinking or growing? R equals, and so we'll put an R equals 4/11 in here. R equals 4/11. Let me write it down here. R equals 4/11. So we're going to scale it, dilate it. Now you think about the trick we just did and how we might scale each one of these points. Remember, use the trick from the last slide. And what do you know about A prime, B prime relative to AB? So if I draw this line AB here, right, I'm going to draw a line AB. I'm going to have a line segment A prime, B prime, and how is it going to be relative to AB? Think about that. Specific, and also the length. How long is A prime, B prime? Okay, so now I want you to pause. Whoops. Pause and try. Pause and try. Use our tricks from the last slide. Okay, I assume that you are now back. So we're going to do the same trick. Let's dilate point A. So let's drop it down. We're going to create point C right here. We're going to use that same trick. We're going to drop it down. Now, let's dilate point C. We know how to dilate point C because OC is 11. So OC is 11. So OC, the length of OC, R times the length of OC is going to be the length of O prime C prime, right? That's our fundamental theorem of similarity. So if OC, how far is that? That's 11. Our R is 4/11. So 4/11 times 11, we turn this into a fraction. Cancel, cancel, and we get 4. So O prime C prime must be 4. So our C prime must live right here. Because this is 4. Now we're off to the races. We know that when we dilate points, these points now, if we dilate them, they all must be parallel. So if we dilated C to C prime, A must be on a line, A prime must be on a line that makes A prime C prime parallel to line AC. So let's just go ahead and draw that line in. This is our line that's parallel. Now the other thing is, if we know that if we dilate a point AC, if we dilate A to a point A prime, it must be on the same line as OA. So let's do that now. So we know our A, we can identify our point A prime. It must be right, whoops, let's get rid of that. Let's draw it with a dot. And here is our A prime. Right there. Let's do the same thing with B now. Our B, let's make that in light blue. So B prime. Okay. Let's just go ahead and draw in our AB prime and our and let's draw in our AB. Okay. So that's pretty cool how we did that. We had to use this trick of C, finding point C, to find out where C prime is, to find out where our parallel line was going to start. And then we could just draw it. Because we couldn't find 4/11ths of this distance without kind of using a ruler and doing an estimation. But we could exactly figure it out if we dropped it down straight to the x-axis and found 4/11ths, because it fell right neatly on this number 11. 4/11ths of 11 is 4, which we can quickly show with math. And then we know that A prime and B prime must live on this line. Why? A prime and B prime are parallel to AB. Line segment AB prime, A prime, B prime is parallel. So there we have it. Oh, and the length. Now finally, the length of AB, A prime, B prime, is 4/11ths the length of line segment AB. That's the relationship. Right? Which makes sense. It's smaller. 4/11ths is about, it's about 0.36, I think. Wait, it's 0.09. Yeah, 0.36, 0.37, somewhere in there. So this is about a third the length of this, which looks about right. Okay, so let's put a big happy cat bow on this one. Now, again, just listening to these videos by themselves doesn't mean that you can ignore your teacher in class, because your teacher, you did a lot more work throughout the hour of your class lesson that you did by listening to me for 25 minutes. However, the point here is to make sure that you reinforce. What I'm trying to do is just kind of help you reinforce what you learned in class and give you a little bit of extra help on the homework. Hopefully you try these homework problems. When I give them to you, pause and give it a try rather than just watch your way through them. You will learn a lot more if you give yourself the opportunity to do it yourself before you watch me do it for you. All right, let's move on to lesson 6 next time. But for now, over and out. Have a great math day.